Hello, welcome to lesson 1.f, factoring quadratics and quadratic inequalities. So essentially this is going to wrap up what we're talking about for quadratic, manipulating quadratics. We need to close the circle and talk about factoring. But the objectives here are that at the end of it you're going to be able to use the roots of the quadratic, in other words all of the methods that we've been talking about, in order to factor it. I know that you know how to factor completed squares now, or perfect squares, but other stuff too. And I also want you to be able to interpret a quadratic to see where it's positive and negative. So, to start us off, oh geez, the tablet's doing a thing, hold on. To start us off, let's say my sister and her husband come over for dinner, and I want to entertain them, and because I'm a mathematician, I have a very fun game for them to play. The game is called Find the Roots of a Function, of a quadratic function. So we're going to play Find the Roots. So I give Kevin, I give him the function 2x squared plus 2x minus 4. And I give Liz the function 2 times x minus 1, x plus 2. And I ask them to find the roots. In other words, figure out where the function is equal to 0. Now, the fun thing here is that I've secretly given them the same function. So let's see how each of them does it. Kevin's going to use the quadratic formula. So he's going to say big A is equal to 2, big B is equal to 2, big C is equal to minus 4, and then so it's minus 2 plus or minus square root. B squared is 4 minus 4 times 2 times minus 4, all divided by 2 times 2. So that's equal to minus 2 plus or minus square root. Alright, so 4 times 4 times 2, that's 32, so it's plus 32. All divided by 4. Which is equal to minus 2 plus or minus square root 36 divided by 4. Alright, so there's one root, a positive one, which is minus 2 plus 6 over 4, which is 4 over 4, which is 1. So one of the roots is 1, and the other one, it's minus 2 minus 6 over 4. So that's minus 8 over 4, so that's minus 2. So Kevin says one of the roots is 1, and the other roots is 2, and that's the work he did, and you should be pretty familiar with it. Liz, on the other hand, she looks at this expression, and she says, hey, this is a fully factored polynomial. And she says, well, this whole thing might be 0 for one of two reasons. Maybe I've chosen a value of x that makes this term equal to 0. That would be x is equal to 1, or maybe I've chosen a term that would make that one equal to 0, and that's x is equal to minus 2. So there's two roots here, x is equal to minus 1, and x is equal to 2, and then very fantastic, all done. So, what do we conclude from this? We conclude that the completely factored form makes it easy to find roots. Great. Fantastic. So I know that it's useful. If somebody gave me a factored form, I would say, yes, that's a useful thing to have. That doesn't help me find it, really. So Liz and Kevin both enjoy the game because they're nerds. And they say, wow, we had lots of fun. And I go, oh, thank you. and then they want to play another round of it. But here's the thing, I don't have a second equation. I was kind of banking them on them not liking the game, so I didn't prepare a second example. So Kevin goes, well, how about this one? How about g of x is equal to x squared plus 8x plus 15? I want to try this. And I say, well, I don't have a factored form for that. How do I figure out what its factored form is? Well, before I go too on, there's actually a bunch of different they're not techniques. There's a bunch of different strategies that people use to figure out what the factor form of a quadratic is. There's a bunch of techniques you can use, and if you know them from high school, well, that's great. But like I said, they're strategies. They're not surefire. There's one surefire way to figure out what the roots are, and that's to recognize that if I knew what the roots were, the roots of these two numbers that I found using essentially complete the square, essentially the quadratic formula, they have to correspond to the numbers that make one of the factor terms 0 and the numbers that make the other factor term 0, right? Because they both have to work as roots. In other words, I can find these two numbers using the quadratic formula, and that will inform me what these two expressions look like. Let me elaborate here. So first, let me use my quadratic formula. A is equal to 1, B is equal to 8, C is equal to 50. It's always helpful, by the way, to write these out. Don't try to do this part in your head, because you're just gonna... It's really easy to make a mess on these quadratic formula. 1 times 15, all divided by 2 times 1. So that's equal to minus 8 plus or minus square root 64 minus 60 divided by 2. So that's equal to minus 8 plus or minus square root 4 divided by 2. So that's minus 8 plus or minus 2 divided by 2. So one of them is going to be minus 8 plus 2 over 2, which is equal to minus 3. And the other is equal to minus 8 minus 2 over 2, which is minus 5. Okay. So the idea here is I can use these two numbers to fill in the blanks about what the factored form looks like. If I factor g of x, it's going to generally take the following form. There's going to be some number out front times x minus some number, one root, x minus another number. Regardless of how you factor it, regardless of how weird your expression is, this is what it's always going to look like. One of the terms is going to be x minus or plus some number, the other is going to be x minus or plus some other number. And I want to choose these values so that g of x is equal to 0 when x is equal to minus 3 and when x is equal to minus 5. Do you see the trick here? You go, oh geez, well I don't even know what that is. You go, well I don't know what that number out front is, but it's x minus 3, so that when x is equal to minus 3, these two will subtract off and get 0, and x minus 5. So that when x is equal to minus 5, those two will subtract off, give you 0, I'm sorry. Constant, x plus 3, x plus 5. So like I said, this is generally the way to go when it comes to factoring. How do we figure out this number out front? Anybody have any guesses? Well, the idea here is that this this quadratic expression and this quadratic expression are still the same expression. So if I expand this one out, I should get that one. So to figure out what these coefficients are, all I need to do is expand the formula, expand the expression out, and then compare coefficients. So let me multiply this out. This becomes, oh geez, come on, work. There you go. X squared plus 3x plus 5x plus 15. So this becomes k times x squared plus k times 8 times x plus 15 times k. And now all I have to do is figure out what values of k are consistent to make this number equal 8 and this number equal 1 and this number equal, or this number here equal 15. And of course the answer is 1 in this case. So k must be equal to 1. So this finishes my factored form, 1 times x plus 3, x plus 5, and I'm done. Yep, and that's all there is to factoring quadratics. All we have to do is use the quadratic formula to find the roots, and since this form and my factored form have to have the same roots, I can use these numbers to inform what these numbers here have to be. And then all I need to do is figure out what this constant coefficient is. So why don't we try another example? Factor f of x is equal to 5x squared plus 5x minus 30. Oh boy, that's a weird one. So a is equal to 5, and b is equal to 5, and c is equal to minus 30. Minus 5 plus or minus square root. 5 squared is 25, minus 4 times 5 times minus 30. All divided by 2 times 5. So that's minus 5 plus or minus square root 25 plus, actually I'm just going to get my calculator out and evaluate this number inside. It's 625. So it's minus 5 plus or minus, and the square root of 625 is 25 divided by 10. So there's two values. The positive one is when it's minus 5 plus 25 over 10, so that's 2. And the negative one is when it's minus 5 minus 25 over 10 minus 3. So when I factor this, k times x minus some number, x minus some other number, I need to choose these two numbers so that this thing turns to 0 when x is equal to 2, so it's probably 2. And when this thing turns to 0 when x is equal to minus 3, so it's probably plus 3. How about minus 3? All I have to do now is figure out what that coefficient is. I expand this out. K times, you know what? Alright. K times plus x minus 6. So it's kx squared plus kx minus 6 times k. And now I'm going to compare these coefficients. It looks like k would have to be 5. Huh? So if k is equal to 5, minus 6 times k is equal to minus 6 times 5, which is equal to minus 30. Okay, so that matches. Yeah, so k is equal to plus 5. So the factored form of this is equal to 5 times x minus 2 times x plus 3. Okay. So generally speaking, there are other forms that might factor into. Sometimes it's a perfect square, but you already know how to factor a perfect square, right? So for example, if somebody gives you 2x squared plus 4x plus 2, you plug it into the quadratic formula, and you get x plus is equal to -1 and x minus is equal to -1. You can try that one yourself. If these two are the same, it means that the expression is a perfect square. And so g of x is going to look like some constant times x plus 1, like that, or constant times x plus 1 all squared, and then you still need to find the value of k. So you do this by expanding this out. K x plus x squared plus 2x plus 1, so it's kx squared plus 2kx plus k. It looks to me like k has to equal 2. So the factored form of this is 2 times x plus 1 all squared. So sometimes there's only one root. If the quadratic formula tells you the same number, then it means it's a perfect square. And finally, there's some expressions like this that have no root. So if you put this into the quadratic formula, you get 0 minus 8, so it's a -8 number, plus or minus 0 divided by 4. Because it's a negative number inside the square roots, there's no solutions. And if there's no roots, you can't determine. You can't factor it. All right. So, so what's the point of all of this? The idea here is that having the factored form of an expression is actually pretty useful in a variety of ways. One of the things it lets you do is figure out where the function is positive or negative. So this expression, there are some values of x where it's a positive number, where f of x is positive. There's some intervals where f of x is negative, and we want to figure out what those intervals are, right? So we might be asked a question: for what interval is f of x bigger than 0? How can we do that? Well, if you have the factored form of the function, it's actually fairly easy. And it comes down to us breaking this down into pieces that are multiplied together. And the important bit here is if you have, if both of these terms are positive, then f of x is going to be positive. If both terms are negative, then f of x, negative times negative, is a positive. And if one is positive, the other negative, f of x is going to be negative. And so using the factored form, we can sort out what the interval is when it's positive or negative. I'm going to use a similar procedure to the one I used in the last in the linear equations to figure out how to answer this particular question. So what I do, I'm gonna cut this all out, delete. Okay, so my trick for writing this out is I'm going to write a number line. And it's helpful if you write where 0 is. Okay. This expression is made out of a bunch of terms that are multiplied together. So there's a 5, and there's x minus 2, and there's x plus 3, right? I know where the roots of each of these terms are. So a 5 is always positive. X minus 2 hinges around when x is equal to 2. When x is bigger than 2, it's positive. When it's less than 2, x minus 2 is a negative number. So when x is, say, 1, it'll be lower than x is equal to 2, so this term's going to be positive, this term's going to be negative. Does that make sense? Alright, so the last term, it hinges around, different color, brown. It hinges around x minus 2. So when x is bigger, x is equal to minus 3. So when x is smaller than this, it's going to be a negative number, and when x is a bigger number than this, it's going to be positive. So what we've done is we've broken in this way of mapping out where each part is positive and negative, we've broken up the line interval into chunks, right? So there's this part here that's less than minus 3. There's this part here between minus 3 and 2, and there's this part here that's bigger than 2. And in each part, our function is only going to have one sign. It's going to be positive or negative, and it's going to be 0 at this part and this part. So I figure out which sign it's going to have by multiplying these together. Positive times a negative is a negative times a negative is a positive. So it's going to be positive over here, and x is equal to minus 3 to plus 2. Positive times a negative, positive times a negative is a negative number, times a positive number is still a negative number. So the number is going to be negative, this part. Last interval. Positive times a negative is a positive, times a positive is also a positive. So my quadratic expression is going to be positive when x is less than minus 3 and when x is bigger than plus 2. Does that make sense? All right. Let me try another one. So the idea here is if I have the factored form of the expression, it's really easy to answer the question, when is it positive, when is it negative? When is this negative? Okay. Draw my axis, that's my x-axis, where 0 is, just so I have a place to look for. And then this expression is made of 3 numbers that are multiplied together. The minus 2 term, the x plus 1 term, and the x minus 4 term. I'm going to write them all there. And then I'm going to chart where each one is positive or negative. So this term is negative everywhere, which is fun. Second term, x plus 1. X plus 1 is going to be, its root is at x is equal to minus 1. So when it's less than minus 1, it's going to be a negative number. And when it's bigger than minus 1, it's going to be a positive number. X minus 4. X minus 4 hinges around plus 4, that's over here. When x minus 4 is bigger than 4, it'll be a positive number. And when it's less than 4, it'll be a negative number. So you do all this charting out, and then you have the x-axis divided into regions, -1 to 4. And now we're going to figure out when the function is positive and negative. In this region here, it's a negative number times a negative number. That's positive times negative. It's going to be a negative number. In this region here, it's a negative number times a positive number. That's a negative. Times a negative number is a positive number. So in this region, it's going to be positive. And in this region, last region, it's negative times positive is negative times positive is negative. So this function is negative in this region here and in this region here when x is less than -1 and when x is bigger than 4. Alright, that's kind of something I want you to be able to do, so look it up. Give it a go. Summary. Here's our medicine wheel. Quadratic formula. Quadratic formula tells us roots, and it's based on completing the square. So completing the square is a procedure that tells us what the quadratic formula is, and the quadratic formula can then tell us what the roots of a quadratic are. Okay? And if you know what the roots are, you can talk about the factored form. All of these concepts are connected. Alright, that's it for this lesson. I'm going to add more lessons a little bit later this week, so I'll talk to you later. Bye-bye.